Hi guys, um, let's revise magnetism. I had left somewhere yesterday. I couldn't complete the whole revision, but yeah, I do remember I have covered toroid, and I was basically, I think, doing force on a moving charge. Okay, and yeah, today we are gonna do work done and the rest of the topics from the work done, and I hope let's finish this at least magnetism ka revision today. Only few things are left in here, not much. And I'm looking for few websites where I can practice questions related to physics as well. I guess my setup is almost done. I just need to put my green tea in here. Okay, so yesterday we studied about the force on moving charge. Of course, force will be applicable only if the charge is moving, otherwise it will be zero. Or it will be also zero in the conditions where the charge is moving parallel or anti-parallel. Okay, and after that we did study about the Fleming's left-hand rule. So today we are going to do work done by magnetic force on a moving charge. Now we know the forces charge into dv sin theta. Okay. Now we also know that force is perpendicular to velocity vector and also to the magnetic field. Okay. So this hence our work done is zero. But from work energy theorem we know work done is equal to change in kinetic energy. Right? Now if work done is zero, so change in kinetic energy will be zero. That is initial kinetic energy is equal to final kinetic energy, which means half mvi initial ka square is equal to half velocity final velocity ka square. From here m and half gets cancelled and we get the magnitude of initial velocity and magnitude of final velocity are equal. It means velocity will remain same, but the direction will keep changing. This is what we get from this. Okay. So magnetic field can, so magnetic इससे influence क्या बनता है कि magnetic field can only influence the direction of the velocity vector, but not the magnitude. This is also an important point, can be asked in 1 mark. Just a second. Next is, okay, just let me write it down because I am also revising it with you guys. So because of work energy theorem, you know work done is equal to zero. So hence work done is equal to change in kinetic energy. So V initial is equal to V final. Hence magnetic field can only influence the direction of the velocity vector, not the magnitude. Magnitude will remain same. Okay. Next, a charged particle moves through a magnetic field in a direction perpendicular to it. Then what will happen? Now a charged particle. Again, it is perpendicular to magnetic field. Okay, so here also we studied a case where it is perpendicular. Correct? So what will happen? Speed remains unchanged because speed is only talks about the magnitude. But because direction will get changed, so velocity will be different. Okay? A particle of mass m, charge q, kinetic energy T enters the transverse uniform magnetic field of induction B. After 3 seconds, the kinetic energy will be. Now, again, if I talk about this, kinetic energy will not change. Okay, because work done is zero. So kinetic energy will remain same. Everything will almost remain same, but the velocity will change, not the magnitude but the direction. So speed will also remain same. Next is Lorentz force. Okay. So what is Lorentz force? Lorentz force is basically a force in which we talk about a force which is getting influenced by both electric and magnetic fields. Okay. So this is a total net force in which we have force due to electric fields and force due to magnetic field. Okay. So because of electric field we know force is Q into E, and because of magnetic field it is Q into B into B, B cross B. So the F net becomes this. So F net, which is Lorentz force, is Fe plus Fm. Okay, so this becomes F net becomes Q into E plus Q into B cross B. We also know one thing about this is that we can take Q common from here. Okay. Motion of a charged particle in a magnetic field. Okay. Now we are talking about if a charged particle is thrown into a magnetic field, what kind of motion can we expect? अभी तक हमने देखा था कि already the charge is moving. So what kind of force we can expect? Now we know about the force. Okay. We know magnetic field will apply some kind of force on that. Now how? If I send a charge into a magnetic field, what kind of we can expect this motion? Will it take right and left turn? How will it be? How will it be? So when the initial velocity is parallel, again the case of parallel, where theta can be 0 or 180. If it is parallel then 0, if it is 180 degree then it is anti-parallel. Now we are taking a case where this is the magnetic field and this is how we are saying it, rather than this L. Okay. So we already know when theta is 0 or 180 degree, force in both the cases will be 0. Okay, so however you will send the particle, it will move in straight line only. Because there is no force acting on the charged particle, so there is no way that the charged particle will take a right or a left turn or will go up or down. It will remain the way it came. If it came in a circular path, it will continue walking in a circular path. So almost we do say that it will continue walking in straight line or it will remain straight. In the case of anti-parallel or parallel magnetic, when the particle is anti-parallel or parallel. Okay. So motion of a charged particle in magnetic field. Correct? Case 1 is anti-parallel or parallel. In both the cases, force remains 0, hence because there is no force, so direction will not change. Hence motion will remain same and it will continue walking in straight line. Okay, next case is when the initial velocity, when it comes 90 degree. Now we know at 90 degree it is maximum. Correct? At perpendicular or 90 degree. Okay. So when we have magnetic field in that direction and velocity somewhere like this. Okay, what will happen now? Now things will happen in this way. The particle, because of the force of magnetic field, will start moving in a circular direction. Okay, so when in the influence, because of the force of this, it will start moving in circular direction. So what will happen in this case? Two forces will be balancing out each other. Because of the circular motion, centripetal force will also be acting, which will be equivalent to the magnetic field here. So Fc is equal to F.L. From where we get, these formulas are very important. It is very important for cyclotron or something. For those formulas. So Fc is equal to F.L. If you remember this much only, you can find the value of R and from there T and all whatever the values will be quite different. But just remember this F is equal to Fc is equal to Fm, which is mv square upon r is equal to qvb sine 90 degree, because this only case works when the sine is 90, theta is 90 degree. Correct? So from here b and b gets cancelled and you get mv upon r is equal to qb, and from here the value of r is mv upon qb. This is important. How to find time period? Time period is distance upon velocity. Okay. Distance here, because it is going in a circular path, so 2 pi r upon velocity. From here, can you calculate velocity? What will be velocity from here? It will be qvb r upon m. Correct? You substitute here. R and R gets cancelled. So you get 2 pi m upon qb. So you see the time period does not depend upon velocity. This is very important. They can ask you in MCQ in this way, how is time period affecting velocity? But if you know the formula, you will remember time period will not get affected because of the velocity. Again, frequency will also not get affected because of velocity, because frequency is dependent on time period. Okay, so now the formulas to be remembered. Also to remember that the velocity taken, the vector will be taken as a perpendicular velocity vector, that is sine theta itself. So r is equal to mv perpendicular upon qb, and t is equal to 2 pi m upon qb. Okay, so I'll write down this case. When theta is 90 degree, what do we have? Because of the force, because of Fb force, that the particle moves in circular direction. Okay, it moves in circular direction. Hence, some centripetal force will be applied on it, which will be balancing the magnetic field. Because of that, we get mv square upon r is equal to qvb sine 90. From here, r we get as mv upon qb. If we need to calculate time period is 2 pi r upon velocity, distance upon velocity. Okay, so time period is equal to 2 pi m qb. Okay, time period does not depend upon velocity. Also, frequency is equal to 1 by time period. This is what you have to remember. Next, under the influence of a uniform magnetic field, a charged particle moves in a constant speed v in a circle of radius r, then the time period is, of course, it is 2 pi m upon qb. Now it is independent of both r and b. You can see. An electron is moving in a circular path under the influence of a transverse. Transverse means 90 degree magnetic field of this. If the value of E upon R, M, that is Q upon N, is this, the frequency is Rs. It's very simple. You know frequency? Frequency is 1 by T. So you know it will be QB 2 pi M. Q upon M का तो उन्होंने हमने ले दिया है. Plus they have given us B. We also know 2 or pi का value. Substitute all the values and you get around 10 to 9 hertz. Okay, 10 to 9 is giga, and 10 raised to power 6 is giga. So you get 1 gigahertz. Now we'll write R in the terms of linear momentum, kinetic energy, and accelerating voltage. This is voltage, remember it's not velocity. Okay? Now let me see what else is there. Whoa. Right? I've taken it right long. This is important for cyclotron as the these formulas are made for cyclotron. Okay. Cover half of the topics in this one. But after this changes, you get PL, PIL. What else do we get? And resonance. Let me see it from my quick note video. Okay. Half mv square, right? Half mv square. Okay, got it. Okay, so now what's happening is basically we know mv is momentum, so simply we get radius equal to momentum upon qb. That's how you get this. Then we also know that there is a relationship between momentum and kinetic energy. So the momentum is, you can substitute momentum as equal to 2k kinetic energy to m. And that is what they have directly substituted in here. We also know that the work done is equal to charge into change in what was V? Charge into electric potential. That is work done. I didn't understand this part. Ionized hydrogen atom, that is H positive. Okay. Ionized hydrogen atom, which is H positive, and alpha particle, which is alpha particle or helium 2 positive. They both enter at a perpendicular at a constant magnetic field. What is the ratio of their radii of their paths? Okay. So now we know radius is directly proportional to P upon QB. Both will have the same mass, will also have same. Magnetic field is also mentioned to be same. The only parameter which will be changing is Q. So R inversely proportional to Q. Q is charge. Charge on both will be not same. Charge on hydrogen is 1 electron and charge on alpha particle is 2 electron. So basically it is 2:1. A proton and an alpha particle both enter a region of uniform magnetic field. Proton is again ionized hydrogen atom. Okay. Proton or ionized hydrogen atom is H positive. And an alpha particle both enter magnetic field at right angles if the radius of them is equal. Now the same R is equal. And the Ke acquired by the proton, इसका Ke is MeV, active one. Then the energy by the alpha particle, इसका 1 MeV then. Okay. Now we know radius is equal to 2 kinetic energy M upon QV. Okay. So, in both the cases, 2m kinetic energy will be different here. 2m kinetic energy will be different here. Upon q plus k upon q plus k. So roots and roots gets cancelled, 2 and 2 gets cancelled. Now the mass of ionized hydrogen atom is 1 and kinetic energy is 1. We have already given, and you know Q plus square is basically E plus square here. We know that it will be 4 and here kinetic energy we don't know, and it goes to E plus square. This is basically 4. So 4 and 4 gets cancelled, M and M gets cancelled, E square plus 4 gets cancelled. So again K is equal to 1 MeV. If proton carrying 1 MeV kinetic energy moving in a circular path of radius R in a uniform magnetic field, what should be the energy of an alpha particle to describe this? If something there was more problem. प्रोटॉन का काइनेटिक एनर्जी दिया हुआ है, इट्स मूविंग इन अ सर्कुलर पाथ। पूछ रहे हैं कि अल्फा पार्टिकल का क्या होना चाहिए एनर्जी फॉर द सेम वेवलेंथ। इट्स अ सिमिलर वन टू द प्रीवियस क्वेश्चन। अल्फा पार्टिकल एंड प्रोटॉन। Okay. Again, kinetic energy is 1 MeV. This is same as previous question, but it is asked in a different way, and you get the same answer. Kinetic energy is equal to 1. In a mass spectrometer used for measuring the masses of ions, the ions are initially estimated by an electric potential V, and then made to describe semicircular path R using a magnetic field B. So basically, we have a mass spectrometer here. It is used for measuring the masses of the ions. Okay. So the ions are initially charged by some potential V, and then they are described to some semicircular path of magnetic field. But they are influenced in electric, then magnetic field. If B and B are kept constant, the electric potential and the magnetic field constant, then they are asking the ratio of charge of the ion, that is Q upon M का ratio पूछना है. Okay, they are asking Q upon M. Now we know kinetic energy. We just now studied is equal to work done, which is equal to Q into electric potential. Correct? And we know R is equal to NB upon QB. If I see from here, I can get this. Okay. I can write MB as 2MK. Okay. From there, I can substitute K as QB. Okay. Now, if I do double squaring both, or I do squaring both the sides, I get this. And from here. So basically, why I did that? Because we are given with the kinetic energy. Okay. And because we have to apply somewhere, we have to show a relation between Q. Kinetic energy should not go away. Because of that only we have done this. When the initial velocity is at some angle, now we are talking about the case 3. We have spoke about two cases, that anti-parallel and parallel and perpendicular. Now if it is rejected at some theta, how will it be? Okay. So we know V sin theta, this will be acting perpendicular. So this will lead you to the circular motion. But V cos theta will be parallel or anti-parallel. So this will give you straight line. Now straight line, combination of straight line and circular motion is helical path. So because of this you get helical path. IR. Okay. So in case 3, when it is at some theta, okay, V sin theta gives us circular motion and V cos theta gives us straight line motion. Combination of both gives us helical path. So here R is equal to MV perpendicular we consider upon QB. As I told you, if it is perpendicular upon क्या लेंगे MV sin theta upon QB. So R is equal to MV sin theta Q. This is similar. Studied. Again T is also similar. T is 2 pi M upon Q. Now they are talking about the horizontal distance covered in one time period. So horizontal distance will be qx, which will be equal to v cos theta, and t will be t. So x is equal to qx t. So x is equal to v cos theta into t, which is pitch. So pitch is the horizontal distance. Furthest pitch is the horizontal distance. Okay, which is qx, which is equal to v cos theta k. Next is the path of charged particle in both electric and magnetic field. Okay. If electric field and magnetic field is parallel, okay, so V will be also parallel to both electric field and magnetic field. So if we have a positive charge, E, V and V, all three are parallel. So what will happen in this case? Okay. So what will be happening in this case is electric force is this QE, and we know in the case of parallel, force on magnetic will become 0. So the only will be getting straight line motion, and the straight line motion will be because of electric field F upon L. Okay. So if we need to find velocity after some t, v is equal to v naught plus at, we can substitute a as qe upon l. So the distance covered will be v naught t plus half at square. Okay. Path of a charged particle in both E and N. Case 1. Distance V1 J. Case 1 is E and B are parallel, so is B parallel. B parallel B gives force is equal to 0. So only Fe is active, hence Fe is equal to QE, and acceleration is equal to QE upon M. We can find straight line motion. Motion वाला तो पार्ट क्लियर हो गया होगा. If we need to find B after some time, then B is equal to V naught plus AP. Substitute A with this, and if we need to find S cover, then S is equal to V naught T plus half A theta square, where again A is a uniform. E and B are acting along the same direction as a certain region. Same direction means parallel. If an electron's projection in the region such that the velocity is pointed in the direction of the fields, okay, then charge they are asking. Okay. So they are saying कि जिस डायरेक्शन में ये तीनों सेम डायरेक्शन में है, पैरेलल एंटी-पैरेलल वाला इक्वेशन है. So F will be 0 and Fe will depend upon charge on electric field. Okay. So because this is a negative charge, okay, so force will be on this side, hence the speed will decrease. We have a second case where E and B are perpendicular. Now three of them become perpendicular. E, B and B are perpendicular. Okay. So because these are perpendicular, we'll be having a different cases of these scenarios as well. First is where magnetic, now both the fields will be active, magnetic as well as electric. So now the first case where magnetic force is greater. Okay. So because magnetic force is greater, hence it will be in the direction of the magnetic force. If it is upward, it will be upward. If it is going downward, then it will be going downward. Again, it will have an parabolic path because one will be straight line and circular together to form a parabolic path. If we have electric force greater, the electric force is acting in direction downwards, so we'll have a direction downwards. The parabolic path will be downwards, where it will be going upwards. If both are same, again, if both are same, then it will be a straight line motion. Okay, this situation is also known as velocity selector because QE is equal to QVT sin theta. From here we get velocity as E upon V. Okay. In perpendicular cases only we have three cases. Fm being greater than Fe. This is the diagram. So, parabolic path. Fe greater than Fm, again we will be having a parabolic path. Write down. Fe is equal to Fm. Velocity selector case. This is velocity selector case. Here, velocity is equal to E upon V. A beam of electric charge is moving with a constant velocity in the region of having electric and magnetic fields of strength. Okay, we are given with E and V ka values. Again, they have told it is in 90 meters. Then what is the velocity of the electron? So which case you will be applying this? V is equal to E upon V. E and V का value दे दिया है. So you substitute here and you get answer as this. A beam of electric passes undeflected through mutually. Okay. If E is switched off and B remains same. Now this is perpendicular का case. E इन्होंने बंद कर दिया, B वहाँ पर है. Okay. Then E move. How will E move? सिर्फ magnetic के केस में तो B it will move in a circular orbit. और अगर B switch off कर देंगे, how is it parabolic? It should be straight and not. Okay, अगर B remove कर देंगे, also remember one thing. जिस वे में आ रहा उसी वे में आएगा. Okay. When a proton is released from rest in a room, okay. When a proton is released from rest in a room, okay, it starts with initial acceleration as towards rest. Okay. When it is projected towards north with a speed of v naught, it moves with an initial acceleration rest towards west. Then E and V are okay. ये रेस्ट पर है, कुछ इनिशियल एक्सेलरेशन है a naught. So if E is equal to m a naught. If it is going in this direction west, it is going up, so then it becomes north. Sorry, 3a naught. अब ये नॉट भी जाने लग गया, ओके गोइंग नॉट एज वेल। तो अब इसमें पी भी आ गया, यहाँ पे मैग्नेटिक फील्ड जो है 0 है। ओके ये रेस्ट पे है ना, तो मैग्नेटिक फील्ड 0 होगी इस केस में, क्योंकि अब इसमें मूव करना शुरू कर दिया, मूविंग पार्टिकल हो गया है, तो कुछ मैग्नेटिक फील्ड आ जाएगा। सो मैग्नेटिक फील्ड प्लस इलेक्ट्रिक फील्ड, ओके। सो हेयर इट इज ई इज इक्वल टू एम ए नॉट, यहाँ से ई निकाल लो, एफ एम प्लस एफ ई इज इक्वल टू एम 3 ए नॉट, दिस इज फॉर मास इनटू एक्सलेरेशन। यू नो यहाँ से हमारे पास ई का वैल्यू आएगा, और पता है एफ ई किसका एम ए हो रहा है, ये क्यू नॉट के बाद क्यू बी टी इज इक्वल टू 2 एम ए नॉट, दिस क्यू बी टी 2 एम 2 into force, कैसे हो पाएगा क्यू बी टी केस 1 है रेस्ट का, when at rest Fm is equal to 0, so Fe is equal to m into acceleration, E into electric field is equal to m into a, okay. Case 2 when it starts moving, so when it starts moving Fm is not equal to 0, so Fe plus Fm is equal to mass into acceleration. Fe is equal to ma naught plus Fm we don't know, and this is 3ma naught. Fm is equal to 2ma naught, okay. We know Fm is equal to 2dB is equal to 2ma naught, so we get B is equal to 2ama naught upon qB, where Q is equal to electric and then potential, sorry not potential, velocity. वाओ हैंडराइटिंग कितना अच्छा आया है, देखना अच्छा है ना, ये बोला हैंडराइटिंग। फालतू की अपडेट करवा ली इसमें। ओके द नेक्स्ट टॉपिक इज साइक्लोट्रॉन, मैंने सुना इससे बहुत कम क्वेश्चन आता है। ओके बैटरी इज डाउन, सो cyclotron is a device which is used to accelerate charged particles. Okay, like protons, neutrons, alpha particles, to set them to a very high voltage. That is why it is also known as a particle accelerator. This is done by making it pass through a limited width of electric field number of times. Okay, but we cannot charge neutrons and electrons, it is only meant for positive particles. It can also be done with the help of perpendicular magnetic field which will rotate the charge number of times in the electric field. मतलब electric field बहुत छोटी है, इसमें magnetic field तुम perpendicular में लगा दोगे तो इसी में गोल गोल घूमता रहेगा, तो हाईली एनर्जेटिक नहीं हो जाता है. So the maximum of the accelerated charged particles, half mv square. When will be the kinetic energy maximum? When we have B maximum. B maximum means R maximum. Okay. During the exit time only it should be maximum. So we know R, which is the final radius, is equal to mb max upon qb. So B max is equal to RQ B upon M. So kinetic energy becomes half m, and we substitute B का स्क्वायर है, एंड दैट्स हाउ यू गेट दिस. ओके. An alternating electric field of frequency mu is applied across. इसका कितना लग रहा है मुझे लग रहा है इसमें. What is this one? So, okay. Okay, next is alternating electric field. Frequency mu is applied across the radius protons, the opening magnetic field and the kinetic energy of the field produced. Yes, okay. So we know frequency is 1 upon T, correct? So we know T is 2 pi m upon QD. So ulta इसका will become QD upon 2 pi m. Correct? Now the frequency is given as mu. Electric. Are you sure we have given charge as E? प्रोटॉन है यहाँ पे. ओके, प्रोटॉन है यहाँ पे. तो प्रोटॉन हमने डाला E B 2 pi m. You will get B from here. काइनेटिक एनर्जी वाला फॉर्मूला तो याद होगा, ऊपर ही तो पढ़ा अभी ये. ठीक है, इसके अंदर अब बी सब्स्टिट्यूट कर दो, काटा पीटी करो तो ये आएगा. ये वाला फॉर्मूला ऐसे याद करने की जरूरत नहीं है, बस ये काम जो हम याद रखना. नाउ इज द टॉपिक फोर्स ऑन अ करंट कैरिंग वायर. अभी तक हमने जो पढ़ा था, फोर्स पढ़ा था हमने एक मूविंग चार्ज पार्टिकल पे, एक चार्ज पार्टिकल पे. अब करंट कैसे कैरी होता है जब बहुत सारे चार्ज पार्टिकल्स मूव कर रहे. तो अब हमारे को एक वायर के ऊपर क्या फोर्स लगेगा वो देखिए. ठीक है, तो इसके ऊपर क्या फैक्टर्स पे हमारा फोर्स डिपेंड करेगा. एक तो हम मैग्नेटिक फील्ड देखेंगे, प्लस उसमें क्या करंट दौड़ है, प्लस उस वायर का कितना लेंथ है उस पर डिपेंड करेगा. इसमें जो हमारा लेंथ वेक्टर है और जो हमारा मैग्नेटिक फील्ड है, ठीक है, दोज आर इन क्रॉस एंड 90 डिग्री वाला हम इसका कंसिडर करेंगे. सो हियर द फोर्स इज आल्सो परपेंडिकुलर टू लेंथ वेक्टर एंड फोर्स इज आल्सो परपेंडिकुलर टू बी, जिसके कारण हमारे पास यहाँ पे क्रॉस वेक्टर फॉर्म हम इसका लेंगे. तो जिसके कारण हमारे पास जो फोर्स आता है वो आता है बिल साइन थीटा. इसको आइडियल साइन थीटा लिखते हैं क्योंकि जो थीटा है दैट इज एन एंगल बिटवीन द लेंथ वेक्टर एंड द बी. पर बोल हम BIL देते हैं, बिल साइन थीटा, बट यू रिमेंबर कि थीटा एंगल किसके बीच है, दैट इज व्हाई इट इज रिटन एज आइडियल. स्पेशल केस क्या है कि साइन थीटा क्या होगा, मैक्सिमम कब होगा जब 90 डिग्री होगा, अदरवाइज तो जीरो ही हो जाएगा. करेक्ट. एंगल बिटवीन, ओके, फाइंड द फोर्स ऑन द वायर. तो फोर्स ऑन द वायर निकालना है. यहाँ पे हमारे को अगर आप देखो ऐसे हमारा ये जा रहा है और ऐसे हमारा ये जा रहा है लेंथ वेक्टर. तो दिस थीटा विल नॉट बी कंसीडर. ये ऐसे ही दिया, ये किसके साथ दिया वो भी समझ में नहीं आता, बट अगर नहीं दिया तो इट इज 90 डिग्री ओनली. ओके, सो दैट इज आवर फोर्स इज बुइंग हियर. डोंट कंसीडर थीटा हियर इज 30 डिग्री. LNP का लेना है, के रिस्पेक्टिव में बोल रहे हैं वो हमें नहीं पता। A straight wire of length this carrying a current this placed in uniform magnetic field, तीनों दे दिया। मैग्नेटिक फील्ड इज परपेंडिकुलर, थीटा भी 90 डिग्री दे दिया, फोर्स निकालने को बोल रहे हैं, सिंपल। A conducting rod of length L, mass m is moving down a smooth inclined plane, ठीक है, ये inclined plane है, इसमें हमारे पास थीटा होगा कुछ और यहाँ से ये नीचे जा रहा है, ठीक है, with velocity v. A current I is flowing in the conductor direction, current I flow कर रहा है, okay, in the direction perpendicular to the paper inwards. A current I is flowing in the conductor direction perpendicular to paper inwards. Okay. A vertical upward. Okay. B ऊपर को लग रहा है और I ऐसे को लग रहा है, करंट जा रहा है, ये ऊपर को है इस डायरेक्शन को। Then the magnitude of B is constant velocity है, acceleration 0 हो जाएगा, तो net force भी 0 हो जाएगा। Okay. So now we know is कि magnetic field इस तरह है, ठीक है। So यहाँ पे हमारे पास क्या किया हमने इसका, ये तो पता होगा, इसका एम जी कॉस थीटा इस तरफ आएगा और इधर एम जी साइन थीटा आएगा, और ये हमारे पास इसका मैग्नेटिक फील्ड है, इसका हमने वेक्टर निकाला है, तो वो एफ कॉस थीटा है, मैग्नेटिक साइन थीटा है। पता नहीं